Well, now we are starting what? Double-ended queue. What is the concept name? Double-ended queue. Double-ended queue. Double-ended queue. Okay, fine. So what is the concept name? Double-ended queue. The short form of representation is DEQUE. Right? And already we have seen double-ended queue using linked list implementation also, right? Fine. Now we are going to do predefined things. Already predefined things are there. We are going to see, right? Now this is a queue, right? See, what is the meaning of double-ended queue? Insertion is done at this end. Queue, normal queue, insertion is done at this end. This is called what? Push underscore back. When you are inserting at this end, I can delete at this end, right? So this is called what? Pop underscore back. So we are inserting at this end, we are deleting at the front end, right? This is called what? Pop underscore front, right? So insertion is done at one end, deletion is done at another end. Now same case, we can insert at front end also. Means what? Push underscore front. Same thing we can delete here also. So what is this one? Pop underscore front. I hope this is very clear, right? Fine. Now first function what we have? Push underscore back. Second function what we have? Push underscore front. Two ways I can insert. What is the third function we have? Pop underscore back, which will try to push the data from the back. Next what we have? Pop underscore front. Right, using these four functions only I am going to call this as a queue. Next, as we told in the queue, we have front and back. So here we are pointing to back to get the last element. Here we are having pointing to the front, that is giving you the next element. So what we have? Fifth one, front. Next we have what? Back. Fine. So similarly we are having some more functions. Let me tell. Already we discussed one function. What is that one? Size function, empty function. So another thing is like we were having emplace there. Here also we will have what? Emplace underscore back. Means if you want to create an object at the last, we are using emplace black. Next, ninth one, no? This is 10th one. So this is what? Emplace underscore front, right? So we can create an object at the starting of the queue. We can create the object at the end of the queue, right? Next we are having some more functions here. Let me write 11th one. We are having a function called clear. We will explain what is clear, okay? Not 10, 11 completed. Next, similarly we discussed there is a function called swap. We'll discuss. Next, there is a function called, try to understand, very important point. As you are trying to navigate in the two directions, we can use a concept called indexing. Very important, this is indexing. So very lengthy concept, indexing. You cannot use indexing. You cannot use indexing when you use stack or queue. When you use stack or queue, right? Next we are having at function. Next we are having what function? At function. Okay. Next similarly we are having insert function. Right? We are having insert function. Next we are having erase function. Not delete. We are calling as a erase function. So these are all the functions that I am going to discuss. These functions I will not discuss because size already I discussed, empty already I discussed, emplace back, emplace front already I discussed. Next what? Front also I discussed, back also I discussed. Next we discussed swap also. Rest of the functions now I am going to discuss. See here, just this is not pop front, right? This is pop front only. This is pop back, right? Fine. So this is pop back. So push, pop, back, pop, front. Right? So this is what we are going to see in the double-ended queue. Now we are going to see all these functions in detail, step by step. We are going to see here. Okay, fine. So before we start, we'll see some other concept also, so that it will be helpful to you. Try to understand. there is an array. We have 4, 14, 24, 34. This is an array, right? Okay, fine. So when we have an array this way, 4, 14, 24, 34, 500, 502, 504, 506, right? Now what I am trying to do, for I is equal to 0, I less than 4, I is equal to I plus 1. Int star p is equal to ARR. Int star p is equal to ARR. So what is the value of ARR? 500. Right? ARR is the array name. That ARR value is copied to p. Now what is the value of p? 500. Right. Now what I am trying to do, printf percentile d star p. Printf percentile d star p. So what is the answer you are going to get? 4. Next what I need to do? Plus p. Whenever I tell plus p, 502. I value 1, 1 less than 4 true, star p. What is star p? 14. Plus p, 504. I value 2, 2 less than 4 true, 2 less than 4 true, star p. What is star p? 24. Plus p, 506. I value 3, 3 less than 4 true, print what? 34. I value p value 508. It is pointing to 508. I value 4, 4 less than 4, false come out. Now see, in this program, p is pointing to the last element or p is pointing to the after the last element. P is pointing to the after last element. Understand? If you can think this is an imaginary element as a last element, then p is pointing to this element, right? So what my intention here? P is pointing to after last element. This is a very important point I am telling. P is pointing to after last element. If you can consider this as an imaginary element present in an array, you can tell p is pointing to an imaginary number, right? So this is what very important point. You remember this, okay? Now try to see, here we are storing this way, okay? Fine. Now I am going to discuss this in different form, okay? Fine. Now always whenever I tell DeQueue, you need to add some elements into queue, and after that we need to get the data, right? We'll see that, okay? See. There are multiple ways. I'll be explaining you all the ways, right? I'll be explaining all the ways. Just you try to come here. First step, using namespace std. Using namespace std, right? Fine. Next, what will I do? Hash include DeQueue. Fine. Next, what will I do? Void main. Void main or int main, I don't have any objection. You can write anything. Next, what can I do? DeQueue int, let me take d. D is an object where it is a type of DeQueue. So this is a DeQueue. What is the size of that? We really don't know. Understand? What is the size of that? We don't know. Initially, either size is 0 or 4 or 8, we don't know. Just understand this is a DeQueue, right? Now what I am trying to do, d dot push underscore back of 10. So we are inserting from this end. So 10 came. Okay. Next what? D dot push underscore back of 20. So what happens? 20 came here. Next what I am doing? D dot push underscore back of 30. Yes, so 30. Next what I am trying to do? D dot push underscore back of 40. So here we have 40. Up to here we are clear, right? Now I want to print the elements. Right? First I will explain in one standard way. This is what the standard way we are going to do. After that we will see so many other ways, right? Fine. Now listen carefully. See, in the case of normal array, you are having what? You are having array base address, but this is an object. Object will not contain base address. Object means entire content. That is the reason, instead of creating a pointer, here we need to create a concept called iterator. Very important point. Now I'm introducing one concept for you. What is that concept? Iterator. Now I need to create an iterator where that iterator should hold DQ starting address. DQ starting address. How do I do that? Is this here? The syntax is DQ int colon iterator. Iterator. Let us take it is equal to d dot begin. What I am writing here? D dot begin. What is the meaning of this line? It is kind of a pointer. It is kind of a pointer which is of type iterator, and it contains what? Begin starting address, means it is pointing to this location. It is pointing to this location, right? Next, what will I do? While we really don't know the length, right? Previously what I wrote, I less than 4 I wrote. I less than 4 I wrote. I don't know yet. That is the reason there is a function every time. It not equal to d dot end. D dot end means this location, right? Why already I told in the previous implementation, we told P is pointing to the last element, or P is pointing to the after last element, P is pointing to the after last element. So d dot end also pointing to this location, right? Well, now we are using iterator concept. So now it is pointing to this object. I want the value. How do you get the value? Cout star it. If I write cout star it, what happens? It value is printed 10. Next, what should I do? Plus it. See how I did in the case of pointers. Here also we are doing same thing internally, right? So plus it means it is here. Not equal, come here. Star it 20. Plus it here. It value 30. Sorry, the it is pointing to this location. Not equal to end. Come here. Print what? 30. Plus it here. This is not equal to end, so print what? 40. Plus it. It is pointing to the last to end. D dot end is also this one only. This is what? D dot end. So that is the reason we discussed in normal our example also, right? So it is also pointing to this location, and d dot end also is giving you that element. So now we are going to get false, then come out, right? So what we did here, we pushed the data and we are printing the data using iterator. Without iterator also we are able to print it. Now I will show you that one also. Okay, fine. Now I will try to print the data in the different way also, right? I'll try to print the data in the different way also. See here, what I am trying to do now. First step, I'll take the size. So int k is equal to d dot size. K is equal to d dot size, right? So what is the value of k now? 4. 1, 2, 3, 4. D dot size is 4. Now what will I do? For I is equal to 0, I less than k, I is equal to I plus 1, right? Comma I also I will take. I is a variable of integer type, right? Now what will I do? Simply I can write cout d of k. That's all, completed. So what I am trying to do, same like array only we are able to use it, right? See what I did, sorry, d of I, right, not k. So d of 0, right? In the DQ we are having indexing also. This is 0, this is 1, this is 2, this is 3, right? Fine. So what I am trying to do here, d of I. First time I value 0, so what is the answer? 10, next time 20, next time, same like array only, same like array. I hope this is very clear. Now we are going to see in another way also. Have you noticed in these two things what is the common point? The common point is we are not deleting any element. But have you observed in the case of queue and in the case of stack, we were deleting the element to reach the next element, right? In the case of DQ, without deleting the element, we are just processing it. That's all. I hope this is very clear. Now let us take, I want to print the data. Like deleting. Instead of this, how can I write? While, can you please tell? Not d dot empty, right? Not d dot empty. Next, what will I do? I want to print the data. How do I print it? Cout d dot print. Whenever I tell d dot print, 10 is printed, right? If again I tell d dot print, 10 is printed. Then what will I do? D dot pop underscore print. d dot pop underscore friend. What is the meaning of pop underscore friend? From the first empty, right? Next pop friend means next pop friend 30 40, right? I hope this is clear. See, first approach we used iterator, second approach we used what? Indexing. Second approach we used what? Indexing. Now third approach what we are using friend, as we say in the stack and queue, right? What is the difference between this approach and this approach? In this approach, understand, in this approach, very important, we are not deleting the data. In this approach we are deleting the data. See, whenever you tell friend, 10 only coming every time. If you want to get 20, 20 should be friend. How 20 will be friend? If you pop this. I hope this is very clear, right? Now understand, if you are just interested to manipulate the data but not to delete the data, I use which approach? Second approach and first approach. First approach is iterator, second approach is indexing, third approach is our stack queue legacy of stack queue, right? Now when should I use which one? You should know. When should I use which one? You need to know, right? Now what is the problem in this approach? The problem in this approach is, let us take, I want to insert the element at this position. Do you do that way? No. If you write, understand, the requirement is, here I want to update 111. What is the intention here? So how the data will be there? 10 will be there, 20 will be there, try to understand, 111 will be there, 30 will be there, 40 will be there. This is what happening for me, right? But if someone is writing d of 2 is equal to 111, d of 2 is equal to 111, understand, very important point I am telling. If you write d of 2 is equal to 111, 30 is replaced with 111, means what will be the array? 10, 20, 111, 40, right? Understand? If you write d of 2 is equal to 111, what happens? Can you please understand? So this 111 is, sorry, this 30 is replaced with 111, but programmer intention is, I want to insert an element there. I want to insert an element there. I hope this is very clear, right? So what will I do? What will I do? That I will discuss next. Understand? So that is where iterator concept is helpful to me. That is where iterator concept is helpful to me, right? But before going to iterator concept, another interesting point what I am trying to do is, this also can be written as d dot at of 2 is equal to 111. Means what is the meaning? At 2 location in the d, you need to update what value? 111. In the 2 location, we need to update what value? 111, right? So when do we do this kind of things? You will understand when you start working in the projects, right? Fine. Even you can use here iterator object also, right? Fine. So first we discussed what? Iterator way. Second we discussed what? Indexing way. Third we discussed what? Our stack queue way, right? Fine. Now what is our next target? Next our target is what? To use iterator. When do I use iterator? Next I need to discuss to you, right? Fine. Well, now we need to see why iterator is that much powerful to me, right? See here. Let us take, first 2 lines are common. I don't want to write that, no more that one, but that should be there. What I am trying to do? DQ int d is equal to, even another specialty with the DQ what you got, you can directly use the curly brace and start providing the values 10, 20, 30, 40. So if this is your DQ, 10 is first pushed, 20 is next pushed, 30 is next pushed, 40 is pushed, right? Fine. Now to this location I want to assign what? 222 or 111 I need to assign. How do I do that? See here. First step what I need to do, I need to create iterator. DQ int : iterator it is equal to d dot begin. Whenever you write int : iterator it is equal to d dot begin, it is pointing to this location. I hope this is very clear, right? Now I want to assign the 111 to which location? This location, right? I want to insert it, right? Then what will I do? You know, see here, d dot insert it plus 2 comma 111. What is the meaning of this line? Where it is pointing, it should move to second location, means it will come here IT will come here, understand? Now IT is moved to second location, understand? Whenever you tell IT plus 2, internally IT is moving to this location. Now what I need to do? I need to insert an element here. Whenever I want to insert an element, 40 will come to this location, 30 will come to this location. So gap is there, then gap is filled with what? 111. So what will be the current content? 10, 20, 111, 40, and iterator is pointing 111, 30 and 40. Now iterator is pointing here, understand? Straight away you cannot use the loop. Then what should I do? Again I need to move IT is equal to d dot begin. What is the meaning of this line? Whenever you write IT is equal to d dot begin, IT will point to this object, right? Fine. Now listen carefully. Now while same thing, IT not equal to d dot end. Next what can I do? Cout star IT plus plus IT, right? This also can be written as what? Cout star IT plus plus, I can use endl also, right? So instead of writing two lines I can convert. So first star ID is executed, next plus is also executed, right? Fine. Now return 0 and this. So insert I am only telling in only one way. So in this position you can insert multiple elements also, right? So understand, insert there is in multiple flavors, but I am just giving you the idea. See, if you want to insert an element into DeQueue, definitely you need to use what? Iterator concept. Definitely you need to use what? Iterator. Without iterator, indexing will replace the data and push pop will not work for me. Okay, fine. Next, another important shortcut is, listen carefully, going forward this entire thing can be replaced with auto. Auto is automatic pointer. Auto is automatic pointer. Internally typecasting is happening. Auto is automatic pointer. Internally typecasting is happening. Okay. So you programmer not required to worry. In the say entire expression can be replaced with what? Auto. Whenever I use auto, internally IT will be converted to what type? Iterator of DeQueue type. Iterator of DeQueue type. So going forward, I will use auto also. I hope this is very clear. Next, another thing I am going to discuss here. Assume this is an empty thing. For example, if you write d dot push underscore front of 10. So 10 is here. Front side I am pushing. If you write d dot push underscore front of 20, what happens? 20 is coming here. See, 20 is coming this way. Previously 20 was coming back of 10, right? Now 20 is coming front of 10. 20 is coming front of 10. Same thing if you write d dot push underscore front of 30. Then what happens? 30 will come here. I hope this is very clear. Fine. Well, now we will see some other functions in DeQueue, right? We will see some functions here. Let us take, we are having here int main. So what I am trying to do is, I am going to create one DeQueue for you. $10, $20, $30, $40. This is one DeQueue we have. Now I will try to create another DeQueue. Int temporary DeQueue is equal to 1, 2, 3. Temporary DeQueue 1, 2, 3, right? Now what I am trying to do, I need to insert 1, 2, 3 into second location. I need to insert 1, 2, 3 into second location. How do we do that? Is here auto IT is equal to d dot begin. So whenever I tell auto IT d dot begin, then what happens? Can you please tell? IT will point to the first element. IT will point to the first element. This is DeQueue. 10 is there, 20 is there, 30 is there, 40 is there. Now IT is pointing to this location, right? Now what I need to do? I need to insert these three elements here. So what should I do here? See, IT dot insert, okay, fine. Now we need to give you three things, right? First thing, at which position you need to insert IT, comma, how many elements you need to insert? 3 elements. You need to insert how many elements? 3 elements. From which position to which position? From 1 to 3, right? So how do you do that? temp dot begin. This is the input iterator start, right? Means temp dot begin will give you this iterator position, comma temp dot end. So completed, right? So begin is inclusive, end is exclusive. What is the meaning of exclusive? So end will be pointing here. So from begin to end. End means not end, exactly end minus 1. End minus 1. So as soon as this statement is completed, like, oh, I want to do it at the second location. No. So IT plus 2, right? IT plus 2 means IT is here, plus 1, plus 2. So at this location, we are going to insert. So what happens here? 10 is there, 20 is there, 1 is there, 2 is there, 3 is there, 30 and 40. I hope this is very clear, right? So 1, 2, 3 are inserted at this position. Okay, fine. So this is one way of inserting. Let us take after this what I am trying to do is, second thing, IT dot insert. This is separate program, this is separate program, understand? Okay, fine. IT plus 2. First we will understand what is IT is pointing to which way, which DQ. This is my DQ. 10 is there, 20 is there, 30 is there, 40 is there, right? IT plus 2 means currently I am standing at to this location, right? 0, 1, 2. That's what it means. Next what I will try to do is 3, 111. The meaning of this statement is we are trying to fill so we are trying to fill IT plus 2 3 times 111, 3 times 111, right? We are filling 111 3 times. Means what happens here? This will be your new vector. Now this will be your new DQ. 10, 20, 111, 111, 111, 30 and 40. So what is the meaning of this one? So 111 is inserted 3 times. 111 is inserted 3 times, right? So totally we are having how many type of insert? 3 types. What is the first one? Insert iterator position, comma iterator position, comma value. Next what we discussed? Insert iterator position, comma iterator position, comma next input start, comma input end, right? Input start is here, input end is here. Next what we discussed here? Insert iterator position, comma number of times and value. So what is the meaning? So we need to insert 111 how many times? 3 times. So we are having 3 type of insert functions. So we are having 3 type of insert functions, right? Now we'll see erase function. Okay, fine. Well, like this is my DQ. Now I want to erase an element. I want to erase an element. How do I erase an element? See here. 10, 20, 30, 40, 50, 60. We assume that way. 50, 60. Now we are having erase 2 types. First one I am going to discuss. First one is like this. See. D dot. I hope previous programs did I tell IT dot? No. If I tell IT dot, you change it. We should write D dot, right? Every time we should write D dot. By mistake, if we told IT dot, no. We should write what? D dot, right? Yes. So every time D is a object name, right? D dot erase. What can I write here? IT. Instead of IT, what can I do straight away? D dot begin. D dot begin plus 2. And here D dot begin I am going to store into IT. Instead of that I am directly writing D dot begin comma plus 2 means what? From 0 go to second location, plus 1 plus 2 means this element is erased. So what is the meaning of this statement? D dot erase of D dot begin plus 2 means what? From begin go to second location and erase that element. Okay, here we are erasing only one element. Here we are erasing only one element. Now second what we have is D dot erase D dot begin plus 1 comma D dot begin plus 4. We'll see the list here. What is the list we are having? 10, 20, 30, 40, 50, 60. So this is what? Inclusive. This is what? Exclusive. This is what? Exclusive. Fine. Now understand d dot begin plus 1. D dot begin plus 1 means this location. Begin plus 4, right? So begin plus 4 means what? 0, 1, 2, 3, 4. This is fourth location. And we told fourth location is exclusive, one location is inclusive, right? So what is happening here? From this to this, these elements are deleted. This is exclusive, right? So what will be the current output if you are printing the DQ? 10 will be there, 50 will be there, 60 will be there in the DQ, right? Fine. Next, what we are trying to do here is, listen carefully. Another important function I am going to discuss, that is d dot clear. Whenever I tell d dot clear, what happens, what are the elements in the DQ? 10, 20, 30, 40, 50, 60. Understand? So whenever I tell d dot clear, all the elements are cleared, all the elements are deleted, all the elements are removed, right? Fine. So whether DQ is also deleted or not deleted, you need to know. Understand, DQ is not deleted, all the elements in the DQ are deleted. What is the proof? I can print it, right? See out d dot size. So now the effective size will be what? 0. Means what? DQ is existing with size what? 0. I hope this is very clear, right? So try to understand. Erase, we can erase one particular element or range of elements also, and try to understand, we can clear all the elements also, right? Fine. Now one important point you need to remember is, let us take, I want to erase the last element. So what do you need to do? D dot end minus 1 you should write, right? D dot end minus 1 you need to write. Instead of that, simply I can do what? D dot pop underscore back. I hope this is very clear, right? If I tell d dot pop underscore back, last element is deleted, right? If you want to delete the first element, what I can tell? D dot pop underscore front. So you can use any one, right? So pop underscore back will delete the last element, pop underscore front will delete the first element, and instead of writing like this, right? If you want to write like this, how do you write actually? D dot erase of d dot end minus 1 you should write. Instead of writing like this, simply I am able to write like this. No, this is not a good programming practice in here. Okay, fine. So with this, we have completed what? DQ implementation. Fine.